Hello everyone! Para sa video na to, ang pag-uusapan natin ay limits at infinity. Let us have some definitions first. Let f be a function defined on an interval c and then positive infinity for some number c. Then the limit of f as x increases without bound, ibig sabihin yung value ng x natin ay palaki lang siya ng palaki is a value L. We write this as limit of our function f of x as x approaches positive infinity. So, kinukuha natin yung value ng limit habang yung x natin ay palaki lang ng palaki and our answer is L. Kasi if the values of our function gets closer and closer sa isang value lang ng L habang palaki ng palaki yung value ng x, then we can say that we can have this value L as our x becomes larger and larger as it approaches our positive infinity. So we can have a value para sa ating limit. So let me illustrate it to you. Consider the function f of x is equal to x plus 4 over x plus 1. We have to complete the table of values below. Aalamin natin ano yung value ng function ng f of x habang yung x natin ay palaki ng palaki. Kagaya na nakikita natin dito, we start at 1 and then naging 10, tapos 100, 1,000, and then 10,000. Kukuhanin natin ang value ng function natin habang yung x natin ay palaki ng palaki, thus approaching positive infinity. So let us have this. Ito na yung sagot. Pero as we evaluate our function, let us start with 1. If our f, and then we have function here, x is 1, f of 1, this is equal to, as we evaluate, ang gagawin lang natin, ipapalit natin yung input natin na 1 sa lahat ng value ng x. So this will become x plus 4 is 1 plus 4, tapos yung x plus 1 will become 1 plus 1. And then 1 plus 4 is 5, over 1 plus 1 is 2, 5 over 2 is just equal to 2.5. Tapos kapag ang pinalit naman natin kay x is 10, we have this answer. Tapos yung 100, ang pinalit kay x, we have this answer hanggang kay 10,000. Pwede pa naman natin siyang extend, pero we can already observe. Kasi as x increases without bound, habang palaki ng palaki, yung value ng x natin, yung function approaches a certain value. And it approaches 1. Ibig sabihin, palapit ng palapit yung value ng function sa 1 habang palaki ng palaki yung value ng x as it approaches positive infinity. Thus we say, limit of our function x plus 4 over x plus 1 as x approaches positive infinity is equal to, saan siya papalapit? Siya ay papalapit sa positive 1. So ito yung kaso natin wherein meron tayong value ng limit habang yung x natin is approaching positive infinity. So now let us proceed with our next one. Let f be a function defined on some c and then going towards negative infinity for some number c. Yung limit ng function as x decreases without bound. Ibig sabihin, pababa ng pababa yung value ng x naman natin is equal to L, which is written as limit of f of x of our function as x approaches negative infinity. Yung value naman ng x natin ay pababa ng pababa kapag yung value ng function natin gets closer and closer, naging papalapit siya, it approaches one and only number L, then this is our limit as x becomes smaller and smaller, thus approaching negative infinity. So let us have this definition, illustrate din natin kagaya nung nauna. Consider the function f of x is equal to 2x plus 10 over x plus 2. Again, we have to complete the table of value. Kung makikita natin, we started at negative 1, tapos pababa ng pababa yung value niya from negative 1 to negative 10, negative 100, negative 1,000, and negative 10,000. We have to evaluate our function again. As we can see here, ito yung sagot. If we started at negative 1, our f of negative 1, this is just equal to 2. Yung x palitan natin na negative 1. 2 times negative 1 plus 10. This is all over. Yung x palitan din na negative 1 plus 2. And then this is equal to 2 times negative 1 is negative 2 plus 10. That is positive 8 over negative 1 plus 2. This is just equal to positive 1. So we have 8 over 1. This is equal to 8 kagaya nung nakikita natin dito. So as we substitute negative 10, ang sagot ay 1.25. As we evaluate, kung makikita natin 1.25 hanggang dito, our function is, as we can observe here, papalapit naman siya ng papalapit sa single value that is positive 2. From here, as you can see, palapit siya ng palapit hanggang dito sa positive 2. Thus, we say that the limit of our function 2x plus 10 over x plus 2 as x approaches negative infinity, habang paliit ng paliit yung value ng x natin, is just equal to positive 2. Kasi papalapit tayo ng papalapit sa positive 2 as we approach negative infinity. Ito yung paraan kung paano tayo makakapag-solve ng limits at infinity using table of values. Medyo mahaba lang kapag ganito yung gagawin. So this is why we will be discussing theorems when it comes to limits at infinity, para mas mapadali yung evaluation natin. So let r be any positive integer, then the limit of our function 1 over x raised to r as x approaches positive infinity is just equal to 0. And also, the limit of 1 over x raised to r, where r again is any positive integer, as x approaches negative infinity naman, is also equal to 0. Kaya kapag nakakita tayo ng limit as x approaches positive infinity or negative infinity nung form na 1 over x raised to r, ang sagot lang natin automatic is just equal to 0. Kasi habang yung value nung nasa denominator natin ay palaki ng palaki, 1 divided by a very large number, we are getting closer to an answer of 0, either kahit galing ka pa sa negative infinity or positive infinity. So let us remember this form. Ngayon, gamitin na natin sila sa ating example. So we have limit of 5 over x cubed as x approaches positive infinity. Para magamit natin yung theorem natin, kasi ang nakalagay doon is 1 over x raised to r. Kaso meron tayong 5 sa numerator. So let us separate. Pwede naman siya. So this is just equal to limit as x approaches positive infinity of, ihiwalay ko si 5, times we have 1 over x raised to 3. Pareho lang naman yung dalawa. So according to our previous theorem, we have 1 over x raised to r. Ang r natin is positive 3. Since we are approaching positive infinity, etong buong part na to will just become 0. So this is equal to 5 times 0, which is equal to 0. Kaya as you can see here, kahit na ano pa yung value no nasa numerator, as long as we can separate 1 over x raised to r, magiging 0 na tong part na to. If we multiply any number by 0, ang sagot lang natin ay 0. So we can do it faster on our next example. So we have our second example. We have limit of 15 over x cubed plus 10 over x as x approaches negative infinity. According to our theorem, kapag 1 over xr, kahit positive infinity or negative infinity yung approaching yung value ng x, then ang sagot pa rin natin is 0. So here, we apply one of our limit theorem, pwede nating ihiwalay yung treatment ng limits natin. So this is equal to limit as x approaches negative infinity. Unahin muna natin yung una. So this is 15 over x cubed plus, ihiwalay natin yung treatment ng pangalawa. We have limit as x approaches negative infinity. Nung pangalawa natin na term, we have 10 over x. So we have 1 over xr, 1 over x cubed. Ito naman 1 over x. Kaya etong part na to, as we evaluate using our previous theorem, this will also become 0. So we have 0 plus 0. The value of our limit is just equal to 0. So this is how we apply our limit theorems. Now let us have more examples na medyo advanced na meron tayong konting manipulation muna na gagawin. So we have here limit of 2x plus 3 over 4 minus x as x approaches positive infinity. Dito meron tayong konting gagawin na effort kasi you will be observing our exponents. We have x and x here. Hahanapin natin ano yung pinakamataas na exponents na meron tayo dun sa polynomials na nasa numerator at nasa denominator. Since both of them, this is just 2x raised to 1, and then this is also 4 minus x raised to 1, ang pinakamataas natin ay x raised to 1 or simply x. Ganito yung gagawin natin kapag ganito yung example. We will be multiplying yung buong function dun sa pinakamataas na exponent ni x. In our case, 1 lang naman, so we will be multiplying it to 1 over x. This is all over 1 over x. Kasi etong part na to is just the same, numerator and denominator. So, para ka lang nag-multiply by 1. Kasi kapag ginawa natin to, so follow the step, this is equal to limit as x approaches positive infinity. Kapag nag-multiply tayo sa numerator, 2x times 1 over x, this is just equal to 2x over x. And then hiwalay na natin, plus 3 times 1 over x, we have 3 over x. Denominator naman tayo, this is all over 4 times 1 over x, so this will become 4 over x minus x times 1 over x, we have x over x. Kasi kapag ginawa natin to, we can divide x divided by x, this is 1. Same here, x divided by x, this is also equal to 1. So this is equal to, sulat natin kung ano yung natira, we have limit as x approaches positive infinity, we have x over x, this will become 1, kaya this will become 2 plus 3 over x all over 4 over x. So this is 4 over x minus x divided by x. This is just 1. So we have negative 1. Then applying our previous theorem, we have our 3 tapos times 1 over x. Yung 1 over x na to will become 0. Kaya etong part na to will become 0. Same here, 4 times 1 over x. Yung limit as x approaches positive infinity ng 1 over x is also 0. Kaya etong part na to, applying our previous theorem, will also become equal to 0. So this will become equal to 2 plus 0 all over, this will become 0 minus 1. So we have 2 over negative 1. Our answer is just equal to negative 2. So the limit of our function 2x plus 3 over 4 minus x as x approaches positive infinity is equal to negative 2. So again, hahanapin lang natin ano yung pinakamataas na exponent ng x natin, both sa numerator at sa denominator, tapos imumultiply natin yung function. The rest is just simplification using algebra and applying our previous theorem on limits at infinity. So let us have more examples. We have example number 4, the limit of 4x squared minus 5x plus 5 all over 6x squared plus 2x minus 1 as x approaches positive infinity. So, titignan natin, we have our x squared sa numerator, meron din tayong x squared sa denominator. So, we have our 2, ito yung pinakamataas na exponent ni x. Kaya ang gagawin natin, same as our previous example, imumultiply natin yung buong function by 1 over yung pinakamataas, x squared. This is all over 1 over x squared. As we multiply our numerator and denominator, this is equal to limit of 4x squared muna tayo times 1 over x squared. So this is just equal to 4x squared all over 1 over x squared to, kaya this is x squared. Hiwalay, minus 5x. Sulat natin minus 5x all over. Nag-multiply ka ulit sa 1 over x squared. So this is over x squared plus, si 5 naman tayo, 5 all over x squared as we multiply by 1 over x squared. So this is all over, denominator tayo, 6x squared times 1 over x squared. So we have 6x squared all over x squared plus, si 2x naman, 2x all over x squared, and then minus 1 times 1 over x squared, we have minus 1 all over x squared. Then our x approaches positive infinity. Then simplify na natin siya algebraically, yung pareho, we have x squared over x squared, this will become 1. Same here, x squared over x squared is 1. Tapos dito naman, we have x over x squared. As we divide exponents with the same base, ang mangyayari lang, so this is x over x squared. So mawawala to, eto babawasan natin ng isa, so because this is x raised to 1. So this will become just x. Same here, x over x squared, mawawala to, as we divide, this will become 1. Kaya kapag tinuloy natin to, this is just equal to the limit of, ang natira dito sa numerator is 4 minus, eto, mawala na si x dito, eto, mababawasan ng isa, so minus 5 over x plus 5 over x squared, and then this is all over denominator, mawawala sa x squared, both numerator and denominator, so this is 6 plus, again, mawawalan tayo nung nasa numerator, yung nasa denominator from x squared, this will become x, so we have 2 over x minus 1 over x squared, as x approaches positive infinity. And then applying our theorems on limits at infinity, we have our 1 over x, we have 1 over x squared. Etong part na to, as we evaluate our limit, will become 0. So this 5 over x squared, same here, 2 over x, and 1 over x squared, magiging 0 din tong part na to. So this is just equal to, tuloy natin dito, we have 4 minus, as we evaluate our limit, 5 over x is just equal to 0 as x approaches positive infinity. Etong part na to will also become 0 plus 0. This is all over 6. We have 6 here plus 2 over x will also become 0. And then 1 over x squared will become 0. Then this is just equal to 4 minus 0 plus 0 is 4. And then this is 6 plus 0 minus 0 is 6. If we get its lowest term ng fraction natin, 4 over 6, this is just equal to 2 over 3. Kaya this is the limit of our function as x approaches positive infinity. Again, balikan ulit natin yung steps. Hinanap natin kung ano yung pinakamataas na exponent ng x. We have x squared, numerator and denominator. I-multiply natin siya 1 over x squared all over 1 over x squared. Then we simplify. And then applying our theorems on limits at infinity. Then eto, 5 over x, saka 5 over x squared, 2 over x, saka 1 over x squared. This will become equal to 0. Kaya ang matitira ay si 4 over 6. That is just equal to 2 over 3. So this is for example number 4. For our last one, we have limit of x squared plus 4x plus 1 over 2x plus 7 as x approaches negative infinity. Again, same as our previous examples, hanapin ulit natin kung ano yung pinakamataas na exponent ng x sa numerator at sa denominator. Sa numerator natin, we have x squared. Kaso, yung nasa denominator natin is just 2x. So, hanapin natin yung common. Since x squared to, wala naman tayong x squared sa denominator, hanapin natin yung susunod na mas mababa sa kanya na pareho sa denominator. So, we will not consider x squared, but we will be considering our x here. So, we will not be considering x squared. Ang imumultiply natin dun sa function natin is 1 over x. So, we multiply 1 over x over 1 over x. Ganito yung gagawin natin kapag magkaiba yung highest exponent sa numerator at sa denominator. So with that, ituloy na lang natin to. Let us solve this algebraically. I-multiply natin si numerator by 1 over x. So we have our limit of, we have x squared times 1 over x. So this is just x squared over x plus 4x times 1 over x. We have 4x over x. 1 times 1 over x. We have 1 over x. So this is all over, denominator naman tayo, 2x times 1 over x, we have 2x over x, plus 7 times 1 over x, we have 7 over x, as x approaches negative infinity. So this is equal to, simplify lang natin, x squared over x, dahil mas mataas yung exponent nung nasa numerator, so dito tayo magbabawas. So since eto ay x raised to 1 lang naman, so x squared over x, bawasan ng isa, mawawala to. Then sa susunod, common naman, we have x sa numerator and x sa denominator. As we divide, this is just equal to 1. Same here, we divide, this is equal to 1. Then ano yung natira? We have our limit of x squared over x. This is just x. Tapos we have x over x. This will become 1, kaya x plus 4. Tapos walang nabago dito. We have our 1 over x. And then this is all over denominator. Mawawala sa x sa numerator at sa denominator, we have 2 plus 7 over x as x approaches negative infinity. Then applying our limit theorems, etong part na to, this will become 0 as we approach negative infinity. Eto, constants lang naman, kaso we have our limit here. Applying another limit theorem, kapag kumukuha tayo ng limit ng x as x approaches any number here, ang gagawin lang natin, kukuhanin natin kung saan siya nag-a-approach, in our case, negative infinity, tapos yun ay magiging sagot. So this is just equal to our x. Since we are approaching negative infinity, this will become negative infinity plus 4, and then this is all over 2. And then we evaluate here, negative infinity, a very large negative number, kahit magdagdag tayo ng 4 sa kanya, halos hindi rin siya maapektuhan, kahit i-divide pa natin siya by 2, the answer is still a very large negative number. So our answer here, as we evaluate our function here, the limit of x squared plus 4x plus 1 over 2x plus 7 as x approaches negative infinity is equal to negative infinity. This is our final answer. Finally, this is the process kung paano tayo makakapag-evaluate ng limits at infinity. Kailangan lang natin ng konting manipulations ng algebra. kailangan din natin ng knowledge when it comes to our theorems ng limits. With that, I hope you have learned something with this lecture video. Thank you for watching.